Hello students, we have additional exercise problem of chapter 7, 7.18 and 7.19 in this video. A question of 18th one is, a circuit containing 80 millihenry inductor and 60 microfarad capacitor is in series. The two are in series and the source voltage is 230 volt, 50 hertz. The resistance of the circuit is negligible. So we will consider R to be 0. And for this circuit, we are asked to obtain the current amplitude and RMS value, obtain the RMS value of potential drop across each element, what is the average power transferred to the inductor, what is the average power transferred to the capacitor, what is the total average power absorbed by the circuit. In the next one, that is in 7.19, we are supposed to consider the same circuit but with resistance value 15 ohm, and then we are asked to obtain the average power transferred to each element of the circuit and total power absorbed. So let us first start with the 7.18 and we start with the list of values. So L is 80 millihenry. It should be considered as 80 into 10 raised to minus 3 Henry. Capacitor is having capacitance 60 microfarad, that is 60 into 10 raised to minus 6 farad. VRMS is 230 volt, frequency is 50 hertz. Obtain current amplitude means maximum value of current, RMS value of current, let me label it as 1, 2. Then what is the average power transferred to the inductor? So power of inductor, power of capacitor and power of the circuit, let it be total power PT, and let me label them as 3, 4 and 5. So the circuit which we are talking about is this circuit where inductor and capacitor both are connected with a source of alternating voltage. The two are connected in series. So we can say that Z for this circuit is, there is no R. So it is simply J omega L minus 1 by omega C, and mod Z, if I consider, mod Z is simply omega L minus 1 by omega C. As you have only imaginary part, the phase, if you plot it on complex plane, you will realize that phase is pi by 2, and hence power factor cos delta is 0. So if you try to find out power across inductor, say I RMS square into XL, power will be 0. If you try to find out power across capacitor, I RMS square XC will be 0, because these two components don't consume any power, they simply store energy, they don't dissipate energy. So power across inductor and capacitor is 0, and hence power of the circuit is also 0. As far as current value is concerned, we know that IRMS is VRMS by mod Z. We have mod Z available here. Okay, so you can substitute mod Z. VRMS is also given 230 volts, so you can substitute 230 value as VRMS and find out IRMS. IM is root 2 times IRMS, so IRMS also you can find out. So this is the first answer, this is second answer, and from this 2 you will get answer of 3, 4 and 5. So that is all about 7.18. Now if I modify this, suppose if I consider a circuit in which I have resistor also, say 15 ohm. So how the things will change? Now instead of this, where mod Z is omega L minus 1 by omega C. For 7.19, my mod Z will be under root R square plus omega L minus 1 by omega C whole square. This will be the case. And then you can use this IRMS formula and find out current and power if required. Power formula is I square R I RMS. You will have to calculate again and then find out I RMS square R. That is the power. Now again, there is no power consumption with inductor. There is no power consumption with capacitor. The two don't consume power. So total power of the circuit is PR plus PL plus PC. But with this to 0, total power is power consumed by resistor only. So that is problem 7.19. So substitute values, carry out calculation and get your answers. Thank you.